Construct perpendicular bisector line P to segment L. I barely see the segment bar, but it is here. So here's segment LM. And if I want to take the bullseye that has the nub on it, place it over L here on the left, I'm going to draw a very large arc. I'm going to estimate where the halfway point is. My arc that's large is between the halfway point and the other end. So I can see here where my first pencil hole is. I'm using pen so it shows up better on your video, but here's my first large arc. I do the same side, and I find it easier to paper since I'm right-handed. Do it again. And where the two intersections are between the arcs, points, I'm going to connect them. I'll change. They wanted me to call this line P. My arrowhead goes on forever. I'll put my lowercase cursive p. I've labeled it. Because this is perpendicular, I need to put in my symbol. That vertical red line is 90 degrees. It's perpendicular to segment, creating 4 90-degree angles. Every time you have two perpendicular, that's always true. I could write this as line P, put my perpendicular symbol, which is an upside down T. I tend to put a symbol in like that because I slant a lot of my writing. Segment LM. I could put a point here at the end, call it whatever letter I want. A lot of times on worksheets you'll see it as, since this already has an M, let G. Okay. LG is congruent to segment M, but then I tick marks and GM to show they're the same length. I could say if I had two segment LG, it would be congruent to the whole segment LM because two halves make a whole. Build on this concept when we start working through the algebra of segment addition. Likewise, I could have said two segments GM, length of GM would be congruent to that large segment LM. I could write this out as segment addition and say plus GM. Notice I'm using my segment bars because I'm using congruent. I'm only here talking about the picture, parts of the picture. So I'm using all my geometry, congruency symbols, and segment bars to show us all about the picture.